Let's make a simple ping utility using assembly, and I'm going to make this with the NASM assembler and on Linux x64. Before diving into the code, let's talk a little bit about ping in general. Your computer sends a packet to the server that you're requesting the ping, and the server returns back an echo reply. So your computer sends a packet called echo request, which is based on the protocol called ICMP. It is expecting that the computer will reply back with an echo reply, and if it did not get a reply after a certain time, your computer assumes that the target is down, and ping will tell you that there was a timeout when connecting to the computer. To implement this, I'm going to use the socket API, and we're going to use a couple of system calls. I'm going to talk a little bit about them in general right now. So the first one is going to be the socket system call, and we're going to use that to initialize the socket in which we're going to use to send and receive the packets. Second one is going to be send-to, which will be used to actually send the packet to the server. Receive, recv, is going to be to receive the packet, the next packet that comes in. Finally, I'm going to use the write system call in order to write a success message if I got everything okay. Notice that I'm going to make this as simple as possible, so I'm not going to get the actual IP address from the command line. It's going to be hard-coded inside of the assembly. So I'm going to start with the global command, and I'm going to expose my entry point, which is going to be _start. Then I'm going to start the data section, and I'm going to define a couple of structures over here. The first structure is going to represent the address that I want to talk with, so I'm going to label this as address. I'm going to start by placing the number 2. That means that this address is an IPv4 address, so define word 2. This means that this will take 2 bytes. Word is 2 bytes. Afterwards, I'm going to define the port to be 0. Port is irrelevant for the type of socket I'm going to open, which is a raw socket. So I can just leave this as 0. Finally, the address. So the address is actually 4 bytes. So I'm just going to communicate with the Google DNS server, which is 8.8.8.8. So I'm going to put 4 bytes of 8. DB is defined byte. Byte is a single byte. Finally, I'm going to use DD, and I'm going to put 2 DD zeros right over here because this structure actually has to be 16 bytes, so I'm just adding a padding here. Afterwards, I'm going to define the structure of the ICMP packet, which is the actual packet that I'm going to send to initiate the ping. So I'm going to name this packet. I'm going to start by specifying the type of the packet, so that's going to be a single byte, and the type is going to be 8. 8 means that we're sending an echo request. Afterwards, I'm going to specify the code, which is also going to be a single byte, and that's just going to be 0. Now I'm going to label the next one as checksum, and this is going to be 2 bytes, so I'm going to define word. And I'll currently place here 9, but we're later going to actually make a not operation on that because that's how you calculate the internet checksum. The checksum here is pretty simple, but the algorithm is a little bit more complicated than that, but due to the fact that my packet almost has no bytes, it just adds up to 9. You'll see soon. Afterwards, we got the identifier, so that's also 2 bytes, so I'm just going to leave this as 0 because the operating system will later fill this in with a value. Finally, the sequence number. For this, I'll just specify 1. The identifier and the sequence are actually used to identify the current packet, so when replies come back in, ping can know which reply is relevant for which request. Afterwards, I'll define the buffer that will receive the next packet coming in. So this will actually receive the packet coming in after sending the request packet. So I'm going to call this buffer, and it's just going to be 1024 times of FF. Afterwards, I'm going to define the success message if the ping was actually successful. So I'm going to call this good. It's just going to be the word good. Now I can start the actual code. So from here on, it's going to be the text section. I'm going to put this in the middle. And I'm going to start the label right over here. This is the entry point. So I'm going to start by calling the socket system call. So that's going to be system call number 41. So I'm going to move into REX41. Then the first argument is going to be the family. So that's going to be RDI. And the family is going to be AF-INET, and that's number 2. That means that we're talking about IPv4. Afterwards, RSI is going to be the type, In this case, the type is going to be a raw socket, so raw socket is number 3. Finally, RDX is going to be the protocol, and the protocol is going to be ICMP. That's the protocol of ping, so that's going to be number 1. Afterwards, I can make the system call, syscall. Afterwards, I get back if everything was okay. I get back on REX the file descriptor of the socket. So I'm going to save it aside into R12. And I'm going to move on to the next call, which is send2. Before making this call, I'm going to actually fix the checksum. So I'm going to do that by running the not operation. And I'm going to do this on 2 bytes, so that's going to be a word. And I'm going to pass in the checksum. This will actually make this a valid checksum, an internet checksum. And now I'm going to call the send2 system call to actually send the packet to the computer. So REX in this case is going to be 44. That's the REX of send2, the system call number. RDI is going to be the file descriptor. We can just pass in R12 that we saved aside, the file descriptor of the socket. RSI is going to be the buffer. The buffer in this case is going to be the packet, so I'm just going to pass packet. The length of the packet is going to be 8 bytes, so that's going to go into RDX. R10 is the next argument. That's going to be the flags, and we can just put in 0 right over here. No need for flags. Next argument is going to be the address structure, so that's going to be in R8. We're going to pass address. Finally, R9 is going to be the last argument, and that's going to be the length of the address structure, in this case 16. Now I can make the system call with syscall. And finally, after sending the packet, assuming everything was successful, I'm going to receive the next packet coming in. I'm going to do that using the recv system call. So that's actually the recv from system call. But we're just going to pass 0 on the last arguments to actually make it act like recv. So I'm going to move into REX 45. Into RDI, I'm going to move the file descriptor of the socket. That's the first argument. Just going to pass in again R12, what we saved aside. RSI is going to be the second argument, and that's going to be the buffer that will receive the packet. So I'm just going to pass in buffer. Afterwards, RDX is going to be the length of the buffer, in this case 1024. R10 is going to be the flags, again, can be 0. R8 is going to be the address, 0 again. And finally, R9 can also be 0. That's the length of the address. Now let's make this system call. And now, assuming everything was successful, we actually have the packet inside the buffer. So now I can just go ahead and compare. I'm going to compare a word. I'm going to actually compare the ICMP type and also the ICMP code. Both are 1 byte, so I'm going to compare both of them to 0, because I'm expecting both of them to be 0 on the echo reply. So the packet that is actually going to come back from receive is going to contain the IP header, and the IP header is the header before the ICMP, and I'm going to actually want to skip that to get to the first byte of the ICMP header, so I can just read the type of the ICMP and the code. So the size of the IP address header is 20 bytes. So I'm going to skip 20 bytes from the start of the buffer to actually get to the start of the ICMP header. And I'm going to compare both of the first bytes of the ICMP header to 0, because that's what I expect on an echo reply, the reply coming back from the server. I'm going to make this as simple as possible. Obviously, you can make a lot more checks to make this actually a good ping utility, but this is just to make it as simple as possible. Afterwards, I'm going to jump to failure if this was not successful. So I'm going to jump if not equal. And afterwards, I'm going to make the success code, which will actually print good on the screen. So for this, I'm going to initialize the write system call. So REX is going to be 1. That's the system call number of write. Afterwards, first argument RDI is going to be 1 as well. The std out file descriptor. Second argument RSI is going to be the buffer to write, which in this case will be hello. Finally, RDX is going to be the count, which is going to be 4 bytes. Sorry, this is not hello, this is good. And good has 4 bytes in the word, so that's why the count is 4. Now let's go ahead and make the system call. Finally, I'm going to define the failure label here. And failure will just jump infinitely. So eventually everything is going to get to the failure label. And I'm skipping exiting the program because this is not the focus of this video. I'm just going to keep this on an infinite loop. Now let's go ahead and save this. It's important to actually run this program with root privileges because to open a raw socket, you have to be root. So I'm going to start by assembling this with NASM. I'm going to pass in x64. Looks like I have an error. Let's take a look at the error here. Right, I misspelled this command. I wrote time here and it's supposed to be times. Let's fix this and run NASM again. Okay, everything was good. Now let's link this with the LD linker. I'm going to link the object file. Now let's go ahead and run this. And you can see it got good. That means that the ping was successful. Now let's give it a different IP address which the ping will not work on. So let's say, for example, instead of pinging the Google DNS, which is 8.8.8.8, let's change this to 7. So it's going to be 7.7.7.7. I'm expecting this to fail. Let's see. As you can see, I don't get any output. That means that was a failure. Thanks for watching and subscribe for more programming videos.